Hello, I am Ethan Frona, along with my partners Max Christofferson, Luke Krupka, Abigail Kraus, Philip Stahl, and Mitchell Erdman, and we are here to present MicroProject number 1 for jet engine turbine blades. To really understand this project and the process of diffusion, we need to learn what a turbine blade is used for. A turbine blade is an individual component that makes up the turbine of a jet engine. The turbine is responsible for generating power to other engine components, such as compression, and the front fans responsible for the movement of air. The turbine is able to extract energy from the combustion chamber. The combustion chamber is where air is forced into a tight chamber where fuel is sprayed onto it, and the mixture of air and fuel is ignited to create thrust. Because of this, the turbine blades experience the highest temperatures and pressures in the engine due to the combustion chamber. Turbine blades must be able to have a high heat resistance and a high creep resistance so they do not fail under these amounts of temperatures and pressures. So they need to be made out of a strong alloy using the process of diffusion.
Diffusion is important in the design and manufacturing of single crystal jet engine turbine blades because the blades need to be able to function in extreme temperatures and under intense pressure. In the production of these blades, a heat treatment process is used to diffuse several layers of different elements and compounds into the crystal. As shown in the photo on this slide, a ceramic topcoat is diffused into the blade. And although microscopic, the ceramic topcoat is extremely important because it makes the blade more resistant to deformation under compressive loading, which the blade experiences because it is used in a high-pressure environment. Other topcoats also protect the blade from deformation due to the extreme temperatures it experiences. Overall, diffusion is important in the manufacturing of single crystal jet engine turbine blades because the process enhances the properties of the single crystal and improves its lifespan.
Imperfections are a major aspect of diffusion that need to be understood when optimizing a material's properties. Two of the most important imperfections pertaining to jet engine turbine blades are vacancies and interstitials. This is because these imperfections aid in the creation of metal alloys. Jet engine turbine blades are often made from a titanium aluminum alloy. This is due to the blades needing to have aspects of both aluminum and titanium. The blades must be lightweight like aluminum so the plane doesn't fall out of the sky while it is flying, and the blades must also have the high heat resistance found in titanium so the blades don't melt due to the high temperatures of the jet engine. By understanding how imperfections relate to diffusion, material scientists were able to optimize the properties of the titanium aluminum the blades are made from.
Two parts of the manufacture of a single crystal turbine blade can be related to the class content. The first of which is grit blasting, which uses an abrasive to both clean the surface and introduce vacancies into the material. These vacancies allow for the diffusion of a bond coat into the single crystal turbine blade, preparing the material for the second coat of ceramic. Additionally, thermal barrier coating, which uses a vaporized ceramic gas to create a thick coat of ceramic on top of the single crystal turbine blade, can be modeled by the first equation, where the higher concentration of ceramic gas or the longer time the ceramic gas is applied can increase the thickness and concentration of ceramic on the surface. Additionally, there is a middle layer in this thermal barrier coating that is created. This is due to the oxygen permeability of the ceramic layer that is increased, as in equation 2, by the high working temperature of the turbine blade.
Nickel superalloys are the primary material used in jet engine turbine blades. One of the most important reasons that a nickel superalloy is used is because of its atomic structure. Nickel has an FCC, or face-centered cubic atomic cell structure, which is the most densely packed atomic cell structure. This makes nickel a great starting material to make an unbelievably strong superalloy. Superalloys are materials that are able to withstand incredible amounts of heat and pressure. To make this specific superalloy, the one used in most jet engine turbine blades, a combination of nickel, cobalt, chromium, aluminum, and yttrium are used. This combination of materials is light and strong, which makes it the perfect material for such an extreme application.
Given the nature of an aircraft, it is of utmost importance that materials in the aircraft are designed to withstand a wide range of conditions. As airplanes rise into the sky and come back down, pressures and temperatures change in drastic ways that affect materials in different ways. This, coupled with the extremely hot temperatures inside jet engines, highlights the necessity for a special material. Fortunately, materials can be altered to maximize the capabilities and durability of a jet turbine. Diffusion is used in order to strengthen turbines and allow them to withstand a greater range of conditions. It is clear that the topics discussed in class are vital in the production of turbine blades.